Alright. So first thing, let's just graph quickly. Practice y sine of theta. That's the parent graph. And when I graph this function, I'm going to graph the major points. And what do I consider the major points? Start with it. Pi over 2. What? Pi. 3 pi over 2 and 2 pi. Okay. Now, okay, how high should this go up to? What on my y? 1. Okay, so if I start with 0, what's sine of 0? 0. What's sine of pi over 2? Sine of pi. Sine of 3 pi over 2. Sine of 2 pi. Very good, and that's your general shape of the graph. Now let's look at that and analyze some things. Is this a continuous function? Yes. Please look. Please. What's my domain? Our real numbers. What's my range? -1 to 1. Why is this a periodic function? Because it continues to do what? Starts with a C. I ride a bicycle. Sickle. Not sickle. I meant cycle. Never mind. I don't know why I was thinking bicycle and cycle. But cycle. Cycle. It cycles. Is everybody good? Okay. So it's known as a periodic function because it cycles. Okay. It cycles. What's my x-intercepts?
Pi. It's pi.
Pi. How do I write it? N pi. For which n is an element of z, integer. Very good. All these questions could be on your quiz on Thursday. That's why I'm going over them every day. Now, next thing I'm going to ask you. Does it have n behavior? No. Why? Because it does what? Starts with an O. Oscillate. Very good. Let's go to cosine. Y equals cosine of theta. Okay, what's cosine of 0? Think about it. What's the order pair for 0? 1, 1, 0. So what's your cosine? 1. Do you see that? What's cosine of pi over 2? 0. Cosine of pi? 3 pi over 2. 2 pi. So notice sine starts at origin, cosine starts up at the amplitude. Alright? Now, going back over. What's the height of the graph? That's referred to as the what? Amplitude. The distance it takes to complete one cycle. Period. There's a lot of vocabulary here. You got to know your vocabulary. Okay? Now, what's your domain? Our number's range. -1 to 1. What is my x-intercepts? You're welcome. Pi over 2n, because it occurs at every half. Very good. Is it continuous? Yes. What's up? Does it have n behavior? No, because it does what? Oscillates. Are we good? Okay. Alright, so you should have watched your video last night that went over the second one right here. The second problem right here. So I'm not doing that one day. What we're going to do is turn over to page 2, okay? And I'm going to skip around. So just follow me. Like I said, you could do this on graph paper. I'm only doing about 3 more of these because you're all intelligent. We're starting the hard ones tomorrow, okay? And doing those the rest of the week. Huh? Wait, that's right there. No. These are on the quiz Thursday. Alright, so let's look at, and they're not hard, it's just time consuming. Alright. Parker, these are your favorite problems, aren't they? Huh? Here we go, number 4. We're going to do number 4 first, and then we'll come back and handle the negative and 3. But number 4, y equals 2 sine 3x. Toby, you can turn your desk whatever way you need to see, honey. It doesn't bother me, okay? Remember to rotate every day in your group. Alright, so first thing I'm going to do, what's my amp, guys? 2. Absolute value of the A value. My A value is 2, so absolute value of that is 2. What's your formula for finding the period? 2 pi over B. What is my B value in this? It says 2 pi over 3. Now, the Y values are easy. Alright, so I'm going to draw my graph. What am I going to go up on my X and Y axis? 2, very good. I'm going to go up to 2. So, 1, 2. Down to negative 2. How many total points am I have on my x-axis? 9. But that includes the origin, so how many more am I have? 8. Okay. Now, how do I find those? I take 2 pi over 3 and divide it by what? 4. So remember, I got to flip it. So I divide by 4. That's going to be times 1/4. That gives me 2 pi over 12, which reduces to pi over 6. So that means I'm going to start with 1/6, pi over 6, and add 1/6 to each other side. So the first one's going to be 1 over 6, 2 over 6, 3 over 6, 4 over 6. Does that make sense? Okay. So this is pi over 6. Now I reduce as I go. So that's 1 pi over 6. What comes after 1 pi over 6? 2 pi over 6. Can 2 pi over 6 reduce to what? Pi over 3. What's 3 pi over 6 reduced to? Pi over 2. 4 pi over 6 reduces to 2 pi over 3. 4 pi over 6 then comes 5 pi over 6. I can't reduce that. 6 pi over 6 reduces to pi. Then comes 7 pi over 6. Then 8 pi over 6 is what? 4 pi over 3. Okay, I have 8 on there, 9 including the origin, so can I stop? Yes, now let's think about this, why this makes sense. What now, buddy? Yes, so I got 8 right here, and then 9 is my origin. These are just on the simple ones right here, okay? Now, let's see why this makes sense. If one cycle is 2 pi over 3, if I want to do 2 cycles, what's 2 pi over 3 plus 2 pi over 3? 4 pi over 3, is it? Did I end up at 4 pi over 3? Remember, when you add fractions, you keep the denominator the same. Alright, so let's graph this. For sine, do I start the origin or amplitude? Origin. Oh, Lord, I messed that up. And I'm going to put little arrows to let me know it keeps going. So that's my graph. Make sure you put your domain in range. What's your domain? All real numbers. What's your range? -2 to 2. That's such a pretty graph. Yes, that's the width. That's the one on the last. If we don't I would like you to, because I just don't like somebody put this and then put a 2 and not put a 2. You know what I'm saying? Alright, we're going to do number 3 next. Y equals negative cosine 1/2 x. Now, what does this problem involve?
I know.
Reflects. Reflects about the what axis when it's out in front? X. It's going to reflect about the X. So just remember, keep that in mind. All right, same way of doing the amplitude. What's your understood A value there? 1. So what's the absolute value of negative 1? 1. Because that's a negative 1 in front of that cosine. All right, now period. What's your formula? 2 pi divided by B. What's your B value? 1/2. So let's think about this. If I got 2 pi divided by 1/2, what's going to happen to that 1/2? Flip. So it'd be 2 pi times 2, isn't it? So what's 2 pi times 2? So my period is 4 pi. I love it when they come out nice like that. Because when I divide that by 4 in a minute, that's going to be a nice number, isn't it? Mm-hmm. All right, so. Now, my amp is 1, so I'm going to put 1 up here.
Which one are you on again?
Number 3. I'm going to make this a half. I just don't love it. So you can see it better, negative 1/2. I just went up by halves on that. It doesn't matter if you just did 1, it's fine. I'm not going to count that wrong. Alright. Now, I take my period 4 pi and I divide by 4. So what is that? 1. So that means I'm going to start 1 pi and add what to it? 1. So it'll be 1 pi, then what? Then? Yep. And so forth. And if I'm doing 2 cycles of this, I'm graphing 2 cycles, I need to go up to what? 8 pi. Because 1 cycle is 4 pi. I need 4 more for 8 pi. Now, when you reflect something, if the point's already on the x-axis, do you move it? Okay. So cosine. Do I start at my origin or do I start at my amp? Amp. Okay. Normally I'm up here, aren't I? But if I'm reflecting, where am I going to be? You see that? So I'll put it down there. This one's normally on the x-axis, isn't it? So it stays. This one would have been down here, but it's going to be up here. So basically just going like this. You talking about end behavior?
No, the endpoint. I mean the x-intercepts.
The x-intercepts you would do pi in. Pi in because it's occurring at every pi value, not one whole. But I'm only gonna ask you for intercepts on your parent functions, okay? All right, what's your domain? All real numbers. My range, -1 to 1. Very good. Now, some people, if you can't do that in your head, guys, if you want to do this, you can do this. If some of you cannot see that in your head, I have allowed students in the past to draw what it would have been and then use that to reflect. You can do that, okay? I drew what it would have been if there would not have been a negative there, and then I just flipped it. If you want to do it like that, you can, okay? All right. Let's look at number 5. What's the difference between these and what we're doing tomorrow? Okay, so let's look here. It says graph sine and cosine by using amplitude and period. So on these type of graphs, we're only doing amplitude and period. Tomorrow, those graphs are moving right, left, up, down, reflect, everything. So you know, like everything we did with transformations, that's coming tomorrow. So if you don't have all that up, down, right, left, you do it easy like this. Tomorrow I'm going to show you how to do it if you got to move it right, left, up, down, reflect, and all that. There's no stretching and shrinking. It's just those other ones I just mentioned, okay? Alright, so here, what is my amplitude on this one right here? 3, very good. My period is 2 pi divided by b. What's your b value? 2. Okay, I'm going to cancel out those 2, so my period is pi. That means it takes a distance of pi to complete one circle. One cycle. I'm going to get that word right. So I'm going to take, now I got to figure out my x coordinates. I take pi and divide it by 4. What is that? 1/4, isn't it? So I'm going to start with 1/4 and I'm going to increase by 1/4. So this is pi over 4. What's 2 pi over 4 give me? Pi over 2. 3 pi over 4. 4 pi over 4 gives me pi. 5 pi over 4 cannot reduce. 6 pi over 4 is 3 pi over 2. 7 pi over 4. 8 pi over 4 gives me 2 pi. Remember, you're going to have 8 points on your x-axis, and then the 9th one is your origin. On these simple graphs, when you do an amplitude and period. Yes?
So, you ever just do that all the time, or just whenever it says graph 2 cycles?
Graph 2 cycles. That's all we're going to graph this entire unit is 2 cycles. Okay. So you're always going to have 9 points. But the ones tomorrow, they move from the origin. So that's why I'm getting you to notice there's 9 points actually, including the origin. These always start at the origin because we're not moving right, left, up, and down yet. Okay? Now, this is sine. So do I start at my origin or up at my amp? Go up to my amp, back down to x-axis, down to my amp, back up. That's so beautiful. I need to put my arrows on there. I got to do better than that to let it know it keeps going. I forgot to put those arrows in my camera on that. We're going to do one more and call it a day. Are you good with that? Now, this one here, I'm not going to have a chance to do that, but couldn't I rewrite that as 1/4 theta? Don't let that throw you off, okay? So you would just do 2 pi divide by 1/4. Does that make sense? Okay, we're going to do number 6. Tonight, you have 5 of these to do. And I'm going to let some of y'all present them tomorrow. So make sure they look nice and neat. So I have y equals cosine pi over x. This is just a weird one. I just want you to see this one. What's my amp? Let's do this quick. Amp is 1. Period is 2 pi over b. What's my b value? Pi. So that's why sometimes it's not a number. Sometimes it can be pi, okay? So what happens to these pi's right here? So you just got to, that's weird. You won't see that much, but your period is 2, okay? Now, so I'm going to take my period 2, divide it by 4. What's that? So your x values would be 1/2. There's no pi in this because your pi canceled out. 1/2 plus 1/2. 1/2. 2 halves is 1. 3 halves. 4 halves. 5 halves. 6 halves. 7 halves. 8 halves. So you got all whole numbers on you. So you start with 1/2 because I took 2 and I divided by 4. And that's how I got a half. So what? 1/2. 2 halves reduced, 3 halves, 4 halves reduced, 5 halves, 6 halves reduced, 7 halves, 8 halves reduced. That makes sense because when we're graphing 2 cycles, I ended on 4 because the first one beats a 2 and you get the next 2. Now cosine, do I start at the origin or my amp? And that's my graph. I think I forgot to put the domain on the range on the other ones, but y'all know how to do domain range. Make sure you include that in your homework, okay? So your domain here will be all real numbers. Your range will be -1 to 1 brackets. Are there any questions on that learning target? You have 5 of these. You do them on graph paper. I need a hand symbol. How do you feel? Okay. I just want to make sure we got the basic ones down before we went to harder ones.